we're looking at the domain of a function, and especially when we're staying in the real number system. One issue is that division by 0 is undefined. We cannot divide by 0. Another issue is that we can't take the square root of a negative number and end up with a real number. Now later on you'll go and you'll see complex numbers and you can deal with square roots of negative, but in the real number system we can't. So we're going to have to restrict these domains. On number 1 we have f of x equal to 1 over x. We can't divide by 0, so our restriction is that the denominator cannot equal 0. X cannot equal 0. That's our restriction. Now what that means is that our domain is going to be all of the numbers to the left of 0 as well as all the numbers to the right of 0, but not including 0. So our domain is made up of x values that are less than 0 and also greater than 0. Now you can write it that way. You could also write it as the union of two different sets. We could say everything from negative infinity up to 0, but not including 0. We would use this symbol if we were including it. Union with everything to the right of 0 up to infinity. So basically, our domain in words would be all real numbers except for 0. All reals except 0. So a few different ways of saying that, either putting it in words or writing it as inequalities or sets. But the bottom line is we can't divide by 0. Number 2, our denominator cannot equal 0. And so if we set that denominator equal to 0 and solve it, we will figure out what value cannot happen. Subtract 3 from each side, we get x equal to negative 3. Our restriction is that x cannot equal negative 3. And so our domain ends up being all the x's less than negative 3 and all the x's greater than negative 3. So that's our domain. Our restriction is that x cannot equal negative 3. We also cannot have the square root of a negative number and get a real number. So think about the x here. X could be 0. Square root of 0 is 0. What number times itself is 0? That's 0. So square root of 0 is fine, but x cannot, that stuff underneath the radical cannot be less than 0. It cannot be negative. And so our restriction is that this can't happen. We cannot have numbers that are less than 0. So x cannot be less than 0. So that means our domain is going to be all the x's that are greater than or equal to 0. 0 can happen. Numbers that are to the right of 0 can happen. But negative numbers, square root of negative is not a real number. In the same way, that stuff underneath the radical, x plus 2, cannot be less than 0. If we solve that, we would subtract 2, and so we get x cannot be less than negative 2. So we can kind of just put a slash through that saying not less than negative 2. So this means our domain is all the numbers to the right of negative 2, including negative 2. If we put negative 2 into that, we get the square root of 0, which is fine. And then any number greater than negative 2 makes that number underneath the radical positive. Again, the stuff underneath the radical cannot be less than 0. So if we solve this equation, or inequality I should say, we can figure out what values can't happen. Add 8 to each side to get 2x is less than 8. Divide by 2, and we get x is less than 4. So that means our restriction is that x cannot be less than 4. So that means our domain is all the numbers to the right of 4. Denominator cannot equal 0. We cannot divide by 0. So if we set the denominator equal to 0, we can solve that to figure out what values give us 0. And so 2x is equal to 1 when we add 1 to each side. Divide by 2, and we get 1/2. And so x equal to 1/2 is the value. That's the value that makes us have division by 0. So our restriction is that x cannot be equal to 1/2, or we can say our domain is everything less than 1/2 and everything greater than 1/2. We're just excluding 1/2. We could say in words, all real numbers except for 1/2. All reals except 1/2. Hope you've enjoyed this video. Got plenty more on my website.